All right, well, this lesson is for my intro econ students, microeconomics. This is a lesson on utility. Specifically, what I'm going to do is I'm going to work through an example with marginal and total utility, and then the consumer's decision-making process to include the budget constraint and how a consumer decides how to allocate a set amount of money, let's say a budget or an income amount, over several options. In this case, we're going to restrict it to just two options so we can do a two-dimensional graph, a good X and a good Y. So we're looking at how consumers make choices and how to spend their money. Quick comment before we get started on utility. And utility, we measure as economists happiness or satisfaction. That's what we use the word utility to refer to. And every individual has their own utility thermometer, I like to say. So everybody has their own individual scales. You cannot compare utility across individuals. We can look at what an individual does when their utility goes up, when their utility goes down. So think of utilities like a scale. It's like the temperature. So we can measure temperature in Celsius or Fahrenheit or even Kelvin. But when it's the same temperature out there and the water freezes, water will freeze. It says 32 on the Fahrenheit thermometer. It says 0 on the Celsius, right? It doesn't matter. The water's still freezing. It's the same degree of temperature. We just measure it slightly different. And then if things warmed up, it'll start to thaw. The water will melt. In both cases, you'll see the thermometer going up above 0 on the Celsius scale, going up above 32 on the Fahrenheit scale. So you don't have to compare the temperatures, but we can look at what's happening when the heat increases. Both scales will go up. And that's the same thing with utility. So although you can't compare one person's 32 utils to another person's 32 utils, right? You can say, okay, if we give people more money, that will more than likely make them happier. Their utility levels should go up, okay? Both of them. In one case, you give somebody $10, two people $10, and one person may really like that $10, and then they may go from a 32 to 100. Another person might go from a 32 to a 45. You can't compare, right? You can't say, it just maybe their scales are off. So I think of this like example I like to give is, when you go to the emergency room, if this has never happened to you, trust me, this is how it goes. And they try and triage you, and they try to get a sense, the doctors try to get a sense of, in how much pain are you? And so sometimes they'll give you a little piece of paper and it'll have all these different emojis, these faces on it, you know, from the guy who's super happy to the guy who obviously number 10 is in the worst pain ever, right? And they say, okay, which of these are you? Okay, I'm like a 6, right? So you can imagine when I was having my children in the middle of childbirth and they're asking me, well, where's your pain at on a scale of 1 to 10? And I'm going a 25, obviously, right? Well, then my husband, another example, we go to the emergency room, he's in a full-blown heart attack, right? He's having a heart attack, cardiac incident, and we're asking him, well, on a scale of 1 to 10, what is your pain level? Oh, about a 5. I'm looking at him going, no, that's bullshit. It's at least a 10, right? So anyways, our scales are slightly different, and that's okay, right? But we can look at it as an individual. How does your marginal utility increase or decrease? And if we added one more unit of something that you like, by how much would that increase your utility? All right, so that's the usefulness of utility. Just remember that when you're looking at these individual consumers, don't put yourself in their shoes. This is an entirely different consumer. We're not asking what would John do, you know, Joe student do. We're asking in this consumer, what did consumer Bob do? Okay, so sometimes that's a little tricky for students. They like to put their own judgment of what the scale should look like onto the examples that I provide. Don't do that. Just look at the information that you're given and respond on behalf of, be the agent for that consumer. Don't put yourself in their shoes. Okay. All right, that being said, what I want to do on this lecture is I have a handout. I will post this handout on Module 5. I believe we're in Module 5 now, in the consumer theory part of the class, understanding how consumers behave and think and make decisions. And so I will post this handout, but I want to walk through this handout, and along the way, we'll fill it out together. Obviously, I'm not going to post the completed one. You can go ahead and rework this on your own. Make sure that you can reproduce the answers that we get here today, right? Before going on and attempting the homework. This will very much help you with the homework, which I just posted. today, and I think it's due next Thursday. All right, so I'm going to open up this handout, which again you can find in Canvas. And let me go to Zoom and make sure, for example, that I'm sharing my screen with you. And so, where do I go here? How do I share my screen? Oh, share screen. Okay, I'll figure this out, right? Thank you for bearing with me. And here we go. So now I have opened up this screen. Okay, that's fine. Little message I got. Hopefully it's still recording. Let me go to my Zoom. It looks like I'm still, you are screen sharing. Okay, good. So hopefully if I minimize this, you guys can see my screen. Okay, and so here's my screen, and this is the example. You can open up this printed example in Canvas. Assume that there are two goods, hamburgers and French fries, that this consumer likes. Those are goods for them, meaning that they provide positive utility, at least in the beginning, right? We'll see if you eat too many hamburgers or too many French fries at one sitting. It could be that you don't like 6 hamburgers at one sitting, because that could really make you sick, for example. But at least these things are goods this consumer likes to buy, and in particular likes to buy them on a regular basis. So let's say they have a budget set aside of $5 that they can spend on hamburgers and French fries over this time period, whatever it is, a week, a month, whatever. Okay. And so what we have here is now a table that shows we've asked the person, what is, after one hamburger, what is your total utility? So we hand them a little handout instead of the faces with the numbers. We say, okay, how many utils, imaginary units that represent happiness, but give us a number approximately. How many utils are you getting from one hamburger? And the person says 20. So you can see I'm here in this table where quantity H is hamburgers, and I've got 1, 2, 3, 4, 5. Many of us don't eat more than 5 hamburgers in one sitting. I suppose if you're a football player or somebody who exercises a lot, has a big metabolism, you may. But 1 through 5. In any case, the point is, even if it's one sitting or not, we only have $5. And I forgot to mention, as was given in the problem here, the hamburgers and the French fries each initially cost $1 each. They're pretty cheap. You can get them off the value menu at the local restaurant, okay? And so that's why I only have 1 through 5, because with our $5 budget, we can't really afford more than 5 hamburgers, okay? So anyways, let's go to total utilities. The first one, the total utility is 2. After the second hamburger, okay, so this is total utility. Total utility takes into account both hamburgers, okay? So after 2 hamburgers, or if they consume 2 hamburgers, that would put them at a level of utility at 35. That is not saying that the second hamburger is 35, right? That's the combined total. So the third hamburger, after they eat that, we go, okay, now how happy are you? After 3 hamburgers, they go, okay, now I'm at a 48. I'm feeling pretty good here, right? So I'm just gonna stop right there, because that's all the total utility numbers that we are given in this problem. But what we wanna look at is not the total utility from 1 hamburger or 2 hamburgers or 3 hamburgers altogether. We wanna look at, what does each hamburger add to your happiness? Okay, and that's called marginal utility. So as you saw in the previous chapter, one of the introductory concepts that we talked about was marginal analysis, buying the next pair of jeans, or the school district hiring the next teacher. In this case, marginal utility is the next unit of consumption. So in this case, the next hamburger. Okay, so starting off, let's assume that we were at a 0 when we had 0 hamburgers, right? That would make sense. We're not very happy. We don't have any hamburgers, right? But then when we added 1 hamburger, it brought us to a level of 20. So that 1 hamburger increased my utility from 0 to 20. So the marginal utility of that hamburger is 20. I'm going to enter a 20. So hopefully you saw right here on the handout on this example that the marginal utility of the first hamburger is 20. Okay. So now, after the second hamburger, we're at 35. Now we're just looking at, what did the second hamburger by itself add? Because we know that the first hamburger was responsible for 20 utils. We're now sitting at 35. So obviously, that second hamburger added 15. So marginal utility, oops, 15, not 16, there we go, 15. Marginal utility is the change in total utility from 35 or 20 to 35, right? Divided by the change in the number of units. In this case, we only went from 1 to 2, so the change was 1. So when I said it was 15, it's really 15 divided by 1. Be careful on problems like in the homework or on a quiz or an exam, if the quantities go up by 10s or they go up by 20s, right? Think about a pack of M&Ms. It might be like 50 M&Ms in that package that you consume, right? So you would divide by 50, okay, in that case, however the units are packaged, okay? So in this case, it's the change in total utility divided by the change in quantity. So in this case, a change in total utility was a positive 15 divided by a change in quantity of 1. That gives me 15 for the marginal utility. I'm going to record that here in the third column, and that's where this 15, I just highlighted it for you so you can see. All right, let's do it again. So from the second unit to the third unit, my total utility, my thermometer, went up from 35 to 48. Knowing that the two previous burgers combined for 35 of that 48, we know that the third hamburger is responsible for the change. 48 minus 35, in this case, it's 13. Oops, I tried to use my keypad. I guess I had my number lock on. There we go, 13. Okay, so you can see here, the marginal utility of the third hamburger is the change from 35 to 48, from 35 here to 48, okay? And so that's 13. All right, let me do the next one. I'm not told what the total utility is, but you can see that the fourth hamburger is going to add 10. Its marginal utility, so the extra happiness that the fourth burger is going to add is 10. So I can take that the 48 that we were at before with 3 hamburgers, I can add the 10, see the 10 right here that I just highlighted, and I'm going to add that to the 48. So after consuming 4 hamburgers, I'm at a level of 58 total utils, okay? 48 utils was due to the first 3 hamburgers, and 10 utils were the additional of the 4th hamburger. Same thing for finding out the total utility of 5 hamburgers. I'm at 58 after eating 4 hamburgers. When I look at my marginal utility of the next hamburger, the 5th hamburger has a marginal utility of 8 right here in the table. When I add that to the 58, I'm going to get 66. So now I have the total utilities and the marginal utilities for my hamburgers. Let's jump over here. Let's skip this marginal utility divided by price column for the moment. We'll come back to that. Let's look at the French fries. So the French fries are over here on this side. Okay, so what we did, we just did the hamburgers. Now we're gonna do the same thing over here for my French fries. Okay, exact same process. So the first hamburger, after eating 1, we're at 19. Assuming that we started at a level of 0, that's a really good assumption. When you don't have any, you don't have any happiness due to those, right? And so in this case, 19 is how much the first fry added. Knowing the first fry added 19, and after 2 fries, we're at 32 total, the change in my total utility from 32 to 19 was due to the second fry adding 13. So the second fry adds 13, its marginal utility is 13. Then the third fry, in this case, after eating 3 fries, we're at a level of 40. Knowing that the first 2 fries added 32 combined, then the third fry obviously added the difference. 40 minus 32 is 8. And that's how you would get these marginal utilities. So then for the fourth one, the fourth fry, we are told its marginal utility was 5. So you can add 5 to the previous 3, which was 40. And after 4 fries, we should be at a total utility of 45. Then the 5th one, you can see, is going to add 4 to my total. So 45 plus 4 is 49. Now, what you should do, and I recommend this, okay, and I didn't do it here. I didn't want this video to get too long, but you should go and plot these on separate graphs. On one graph, you should put quantity on the horizontal and total utility on the vertical. and you should plot the total utility. On the next graph, you should plot the same quantities and the same, and then not the same, and then the marginal utilities. We never, ever, ever plot totals and marginals on the same graph. Their units are quite different. Look at, these are all double digits in the totals, and we're down here in the single digits for the marginals. So we use separate graphs for totals and marginals, but we often will stack them on top of each other so that the horizontal axes line up. And the horizontal axes in both cases will be simply quantities 1 through 5. So go ahead and plot those, and you'll get the general shape of the total utility function and the marginal utility function as is shown in the textbook. So once you plot that, open up the textbook to chapter 6. This is the marginal utility stuff, or the utility chapter. And you should see that your curves look very similar to the curves that are shown in the book. So in particular, total utility rises all the way, 19, 32, 40, 45, 49. All of this is rising because my marginal utilities are all positive. If we had eaten the 6th French fry, let's say, and it had made me sick, my marginal utility might actually be negative, and that would take my total utility down. So let's say maybe it was a -3, it would take my total utility down to a 46. In that case, then your total utility curve would level off and start to fall, you know, be like a quadratic shape or parabola, okay? The marginal utility, though, in this case, it decreases everywhere, 19, 13, 8, 5, 4. So if you plotted that, that's gonna plot as a pretty much predominantly downward sloping curve, right? So very different. One curve is upward sloping. And those of you that know calculus would notice that this total utility function, it rises in the beginning, initially relatively steeply, and then at slower intervals. So it does, in fact, slow down as it approaches its maximum prior to just falling, okay? So it is not linear in this case. All right, so there you go. If you plot those, that's what you should see. Now, what we want to look at is we want to compare marginal utilities per dollar, because different goods sometimes have different prices. I know in this example, we're starting out with both hamburgers and french fries being 1, and that's just a convenience in the beginning. You're going to see in the second part of the problem, I am going to change the price of hamburgers. It's going to go up to $2, and we're going to see what happens, okay? But what we want to do is we want to control for that, because let's say sodas were $2 each or $3, right? Then if we added that to the mix, we would want to look at not just marginal utility, but marginal utility per dollar. So we're talking about, and the book mentions this, and I love that the author of this book uses the same term as me. Marginal utility per dollar is the same as more bang for your buck. So you want to have more marginal utilities per dollar, right? So you're buying units of happiness, and we express it as dividing by price or standardizing. So then the denominator is always $1, right? Eventually. So it's going to be marginal utility per $1, okay? And so that's what this is going to be in this case. And in fact, the price is $1. So my marginal utility per dollar is going to be pretty easy. In all of these cases, I'm just going to divide by 1. So it's going to be the same number. So I'm going to go ahead and fill this out. You're going to see in the next part that it's not. That's why I know you're wondering, why are we bothering doing this? But 13, 10 divided by 1, 8 divided by 1. I go over here, 19 divided by 1, 13 divided by 1, 8 divided by 1. 5 divided by 1 and 4 divided by 1. All right, so let me highlight these. And in fact, let's see if I can color these. And this guy, let's make that one yellow. Kind of wanted the whole thing yellow. Anyways, that'll work. And these guys, let's make these guys green. Okay, so there we go. This is what we're going to be looking at. So part A, calculate the marginal utility and marginal utility per dollar for each of the goods above. And we did that. We've got our marginal utility for our hamburgers, marginal utility for french fries, and then we divided by the $1. Now we're going to say, okay, let's look at what can the consumer afford. Let's look at their budget constraint. So in the beginning, if their budget constraint is $5, right, we're going to assume that the consumer is going to spend all of their $5. They've allocated this money to hamburger and french fries. They're going to be best off if they spend all $5 on hamburgers and french fries. This is kind of like a PPF. It's like, okay, what can we afford with our $5? It's going to give us a set of choices, and then we have to choose amongst all those choices of how we can spend our $5, which choice is going to make us happiest, okay? So let's look at the budget constraint as the set of possible points that we can consume exactly $5. So in this case, here's my little description here. Assume that the consumer will allocate all of their income across the two goods. In this case, hamburgers, I'm going to use H, and French fries, I'm going to use F. And their expenditures, total amount they spend on hamburgers is going to be how many burgers did I buy times the price of each hamburger. And that's how much of my $5 did I spend on hamburgers. On the other hand, if I take the number of French fries times the price of French fries, that's going to give me my total expenditures on French fries. How much of my $5 did I spend on French fries? Okay. And so then just the notation in terms of making up a math equation, let's let PH be the price of hamburgers and PF is the price of fries. My quantities QH is going to represent how many hamburgers and QF is going to be how many fries. So I'm going to allocate my income. My equation is, if I've done it right, if I've allocated all $5, right? Oh, shoot, there's a typo. Let me backspace. And I don't think, oh, wait, equals. Oh, no, I got that right. Oh, no, I did it right. Okay, so far so good. Income is going to be equal to my expenditures on hamburgers plus expenditures on fries, right? And I just changed expenditures on hamburgers to be the price of hamburgers times the quantity of hamburgers, and then the price of fries times the quantity of fries, right? So far so good. Plugging in, substituting income for its current value of $5, plugging in $1 for P of H, the price of hamburgers, and plugging in $1 for the price of fries, we will get $5 is equal to 1QH plus 1QF. That's like the equation of the budget constraint. You know, we typically express equations of straight lines, which you're going to see in just a second, as y equals mx plus b. But in this case, I'm not going to rewrite it. You can, if you were to rewrite this as QH is a function of QF, you can do that, get it into that y equals mx plus b, and you will find the slope, which is actually the slope is the ratio of the prices. It's going to be, in this case, price of fries over price of hamburgers. Okay, it's always P of X over P of Y. Okay, it's not rise over run, P of H and P of S, it's different. Figure out, trust me on this, okay? It's the ratio of the prices, except it's P of X over P of Y. All right, so in this case, when you work through the algebra, if you bother to do that, my math geeks will, okay? So what I'm gonna do now is I'm gonna show this constraint graphically. It's what we do in economics, we graph, we love pictures. So I'm gonna take my $5. If I were to spend my $5 all on hamburgers, right? And given that the price of hamburgers is $1, I could afford at the most 5 hamburgers and I would have 0 French fries because I couldn't afford it. I would have spent all my money, my $5 on hamburgers. On the other hand, if I only bought 4 hamburgers, I would have enough money to buy 1 fry, and that's represented here at point B. If we went all the way to the extreme and I spent my $5 just on French fries and bought no hamburgers, I could afford at here down at F, I could afford 5 French fries and no hamburgers, okay? So this shows me A, B, C, D, E, and F are all the set of possibilities that I could afford with my $5. So I could get 3, for example, I could get 3 hamburgers and 2 fries. I could get 2 hamburgers and 3 fries, and so on, okay? So that's really helpful because it guides my decision making. Unfortunately, if you go to the store, right, because of the discreteness of the units, you typically can't buy 3.5 hamburgers. McDonald's won't sell you 3.5 hamburgers, usually. Now, we get around that in economics. We could say maybe this is his weekly average, and if he would buy 3.5 in a week, what that would translate to is 14 over the course of the month, right? So sometimes when you're looking at these graphs, if you do have a decimal, don't go, oh, no, that's not possible. It is if it's an average of a shorter time period, right? If it's a weekly average, then just go, okay, what is it in the month? Oh, that makes sense, okay? But anyways, in this case, let's just assume discreteness, and he can't buy any half hamburgers or half French fries. All right. So what I wanted to, just that limits my choices on this graph. And that's what I want to do at this intro level for this first example in particular. So you can see over here, I have written for you, points A, B, C, D, E, and F all utilize all of my income. I'll spend all of my $5. I drew point G on the inside to the interior of the red line of the budget constraint. So the red line is called the budget constraint. When I ask you to plot a budget constraint, this is what I'm looking at. I would like you to reproduce. The G would be a combination of 2 hamburgers and 1 French fry. Obviously, I can afford that. That would only cost me $3, and I would have $2 left over. But that's inefficient. I have $2 sitting around that I had set aside just for hamburgers and French fries. So that's an inefficient use of resources. Like I said, very much like a production possibilities frontier. So we wouldn't want to be at G. On the other hand, so point G, we're leaving money on the table, right? Leave money unspent. At H, which is a combination of 3 hamburgers and 3 fries, we can't get there because that would be $6 and I only have 5. So point H is currently an unattainable level in the current period. If I were to get a pay raise or a fiscal stimulus, for example, my budget constraint would shift outward and H could become attainable in a future period. All right, so now, using this, using that budget constraint and the points I have identified, A, B, C, D, E, and F, in this case, now I have identified the possible baskets, and what I want to consider is how happy does each basket make me, okay? So I'm going to list all the points. I started out here with point A, which corresponds to 5 hamburgers, 0 fries, and then I listed down here point F. And we're just going to work through A, B, C, D, E, and F and figure out what is the total utility of those combinations of hamburgers and French fries. And then we can say, okay, well, this consumer is going to choose the one that provides the most utility. It's going to get the highest total utility combined. And that's one way to go about the maximization of total utility. All right. I'm going to pause for 1 second and then come right back. So let me go here. Just a second. How do I pause? I need to pause.
You.
Mm-mm.
Go to Zoom or whatever. What are you doing?
I'm trying to Zoom. I'm trying to, not that one. I want to pause.
All right, just go watch Jeopardy.
Pause record. All right, sorry about that. I had to take a quick break, but I'm back. And so now we're going to look at the total utility of the different options that we found from our budget constraint. So at 5 hamburgers and 0 French fries at point A on this graph, right? Let's go up here and see what would be the total utility. So we're going to go to 5 hamburgers on my chart here. Gives me 66 total utils. I'm not buying any French fries, so 66 total utils is going to be my combined, okay? Let me then go to my next point is going to be 4 hamburgers and 1 French fry, and that's going to be represented by point B on my budget constraint. Look up here at point B, 4 hamburgers, 1 French fry. And let's look at what is the total utility. So we have to add them. So 4 hamburgers is 58 and 1 French fry is 19. 4 hamburgers, total utility of 58, 1 French fry, 19. So when I come down here, I'm going to do 58 plus 19. Let me go back and double check. 58, 19, add those together. And that should be 77. So if the choice was just between A or B, this consumer would clearly like point B better. 77 utils is better than the 66 level of happiness, okay? Let's go then to our next point, walking down that budget constraint. 3 hamburgers, 2 French fries. That's gonna be represented by point C on my graph. Let me go up here. 3 hamburgers, 2 French fries. You can see it right there, okay? Let's find out what the total utilities for those two are. The combination of 3 hamburgers, 48, 2 French fries, 32. 48 and 32. So 48 plus 32, and I believe that's 80. Check my math. Don't need a calculator on that one. I think that's 80. So again, as we go down that budget constraint, we're getting happier. So obviously, this consumer prefers having 3 hamburgers and 2 French fries to the option of having 4 hamburgers and 1 French fry, and obviously prefers it to 5 hamburgers altogether because 80 is much bigger than both 77 or 66. Let's keep going. Now, how about 2 hamburgers and 3 French fries, which is affordable. It's on our budget constraint, shown by point D. So let me go up here. Point D, 2 hamburgers, 3 French fries. 2 hamburgers, 35 on the total utility. 3 French fries, 40. Okay, so 35 for 2 hamburgers plus 40 for 3 French fries. So one more time, that's 35 and 40. I'm going to add those two together. 35 plus 40, and that's 75. Whoa, Nelly, as Keith Jackson would say, if you're a sports fan, college sports fan. Now we've gone down. We've seen that we've gone from 80 level of happiness down to 75. So it's looking like point C is looking pretty good right now. This consumer likes having 3 hamburgers and 2 French fries, as opposed to the opposite, 2 hamburgers and 3 French fries. 80, better than 75. So far, point C is the favorite. Let's keep going and see what happens. 1 hamburger and 4 French fries, represented by point E on my graph. Let me go up here. 1 hamburger, 4 French fries, point E. 1 hamburger gives me 20 udals, 4 French fries, 45. 20 plus 45. 20 plus 45 is going to equal 65, I believe. And now we're going the other direction. My total utility is falling. So clearly you can see then that 80 is going to be the best, but let's just see. 5 French fries, represented by point F here. 5 French fries is only 49 udals. So looking at, of all of my options, the one that's going to maximize my total utility, okay, in this case is this combination at point C. Let me highlight this one right there. That combination there gives me the most utility, okay? So part D here, question D, on the basis of the above, which combination maximizes total utility? This is going to be point C, where the consumer has 3 hamburgers and 2 fries for a total utility of 80 udals. That's the best this consumer can do with their $5 limited budget. Obviously, if we gave them more money, they could buy more of both, and that might make them happier, okay? So now, another way, now this requires that if we do this basket by basket by basket, it requires that there's a finite number or a limited number of options. In this case, we only had A through F, right? 6 choices. What if we had a ton of choices rather than just 6? How would we go about and solve this if we had huge numbers, okay? So this is a little bit slower process of adding up the total utilities, all these possible combinations, and then choosing the most. So there's another way to solve this problem. And this is to compare the marginal utility for dollar for each good and choose where the 2 values are getting the closest. So what we're gonna do here is we're gonna go back and we're gonna say, okay, starting with, let me go back and we're gonna do this item by item. So let's look at this marginal utility per dollar. Go back to the yellow and go back to the green. And we're gonna say, I have my $5 and I'm gonna spend the first dollar on the item that gives me the most utility per dollar, okay? So $5, I'm gonna spend my first dollar. I'm gonna go dollar by dollar in expenditures here, okay? So the first one, my $1, I can buy either my first hamburger or my first French fry. The first hamburger gives me 20 udals per dollar, and my first French fry only gives me 19. So my first purchase is going to be 1 hamburger, Okay, so I'm gonna buy a hamburger. Then we go, okay, well, what am I gonna buy for my second purchase? Okay, so let me walk through this a little bit more. And so let me go over here. So first purchase equals 1 hamburger. Okay, first hamburger. All right, then, right, second purchase is going to be then I have my next dollar. The question then becomes, do I buy the second hamburger, which is going to give me 15 utils per dollar, or do I buy my first fry? My first fry is going to give me 19. Since that's greater than the 15 for the second hamburger, I'm going to buy a fry to go with my hamburger. Okay, so down here then, the next thing I'm going to do, my second purchase is going to be my first French fry. Okay, then, okay, I spent $2. I've got $3 left. So my third purchase, it's either going to be the second hamburger or the second fry. 15 is greater than 13. I'm going to buy the second hamburger. Now, when we get to the third, my fourth choice, let me write that one down, my third choice. My third choice was a hamburger. So third purchase, if I can spell, is my second hamburger. Now, the fourth and the fifth look to be equal. I can get my second French fry or my third hamburger. They're both going to provide 13 utils per dollar. That's where it's equal. That's consumer equilibrium now. The marginal utility per dollar for those two units are exactly equal. And in fact, coincidentally, I can afford both, right? Because I've only spent $3 so far. I can then buy a French fry and another hamburger. I spent my $5, and look at that. The marginal utility per dollar for the last hamburger bought and the last French fry are in fact equal, okay? So in this case, then fourth and fifth equal my third hamburger. Third hamburger and second fry. Now look, that ended up being the exact same as what we decided up here in the red. That exactly, we went through this item by item, dollar by dollar, using on the basis of marginal utility per dollar, and we came out with the same answer, 3 hamburgers, 2 fries, as we did using the total utility approach. But we can stop now. We don't need to go calculate D, E, and F. We know that we're done. Okay, so see how it's a little bit quicker. We didn't have to search for all A through F and then do all the math and then compare them. We just went allocating our money across the marginal utilities per dollar until we run out of money. Easy peasy, right? And we get the same answer. So final purchase or final total in this case ended up being 3 hamburgers and 2 French fries. So you can see, I'm going to put this in red down here to show you we ended up at the same spot either way. Okay, isn't that cool? So this marginal utility per dollar approach works, especially if you've got a whole bunch of options and you don't want to write them all out, you don't want to go through and add up the totals and everything. Working through it systematically, purchase by purchase works. All right, the next thing to think about now is what would happen if the price of the hamburgers changes. So when there's a price change, what we want to know is how is the consumer going to change? And so in this case, I think because I was typing, I bumped everything onto different pages, but hang on. So now, what if the price of hamburgers changes? Okay, suppose that our hamburgers now double from $1 to $2. Let's look at what does the budget constraint do. And I have the budget constraint, the original red line, but now French fries, price of French fries didn't change, so I can still afford 5 French fries. They're still $1 per French fry. But my hamburgers now, I did this right? hamburgers goes to $2. So this is where it becomes this 2.5, right? Which really I can't buy 2.5, right? But if I could, and perhaps on a monthly basis I could if this was weekly data. But in any case, I'm just going to illustrate it here at 2.5 is what I could afford with my $5 divided by 2. I could get 2.5 hamburgers. And that blue line is my new budget constraint. Notice how it has rotated inward. If the prices go up, the budget constraint will rotate inward, okay? On the other hand, if the prices go down, that budget constraint can rotate outward because we can now afford more. If the prices of hamburgers had fallen, we'd be able to buy more with our $5, right? All right, so now the question becomes, now how can we allocate our $5 budget? Okay, and so in this case, I believe these are still the same numbers. So I'm just going to copy and paste these two columns. We've already done this. So let me just do this. I don't know why I went down here. The utilities didn't change. And that's something to keep in mind. Just because the price changed, my utility did not change. Okay, let me get rid of that. So I'm going to paste. Oops, I'm not going to do that. Nope, I am not. Anyways, I'll probably just go through and do these numbers. It'll probably be faster. This is 58 because I'm adding 10, and this one is 66, and then this one was 20, and this one is 15, and this one added 13. And then let me go over here, 45 and 49. I'm stopping because the price has changed. So this column for marginal utility of hamburgers per price of hamburgers is going to be different. Over here for the French fries, it's going to be the same as it was in the original table because the price of French fries did not change. So this is 19, this is 13. Again, I'm just reproducing the numbers from the table before. So then these are the same because I'm just dividing by 1, 19, 13, 8, 5, 4. Okay, but over here, now I'm taking, and let me do this. Let me see if I can highlight this in yellow. Here, now I'm dividing by $2. So the 20 marginal utility divided by the price of $2, this is now 10. And this 15 divided by $2 is going to be 7.5. 13 divided by 2 becomes 6.5. 10 divided by 2 is 5. And 8 divided by 2 is 4. Now, don't worry that these guys aren't attainable because at a price of $2, I can't afford 3, 4, and 5 hamburgers. I still wanted to fill out the marginal utility per dollar anyways, okay? All right, so now let's take our $5, and we're going to compare this yellow column with the French fry column, which didn't change. I'm going to put it back in green. Okay, so now we've got the yellow and the green again, just like before, except this yellow has changed. All right, now I'm going to take my $5, and instead of doing the whole, actually no, instead of doing the whole total thing, let's do the total thing. Based on that new budget constraint, there were only 3 possibilities of whole numbers of hamburgers and French fries that I can afford, not counting that 2.5 hamburgers, right? And so let's figure out what the total utility is. Do it the first approach, the total utility maximization of the total utilities, and add the combined utilities and do it that way. And then we'll do the marginal utility per dollar approach. Again, repeating it now, okay? So 2 hamburgers, 1 French fry, okay? So 2 hamburgers, total utility of 35. 1 French fry is 19. So 35 plus 19, whoops, I forgot the plus sign, plus 19, in that case, that looks like 54 to me. Then 1 hamburger and 3 fries. So 3 fries is 40, 1 hamburger is 20. So 20 plus 40 is going to be 60. And then 0 hamburgers and 5 fries, which I can still afford, is going to be 49. And in this case, it looks like 1 hamburger, 3 French fries is going to be my winner, right? So let me actually go back and do red. There's my winner. Oops, that wasn't right. Oh, now what did I do? Yeah. And the undo button. Okay. There we go. I'll leave it like that. Okay, so that looks like it's going to be the right answer because 60 is bigger than 54. 60 is bigger than 49. So the highest total utility, okay, And then in this case, it looks like it's going to be 1 hamburger, 3 fries. Let's now go to the other approach where we take our $5 and we allocate it on the basis of marginal utility per dollar. So the first item I'm going to buy in this case is I'm going to buy 1 French fry is 19. My first hamburger is only 10 utils per dollar. So obviously I'm going to buy that first French fry. That's going to be minus $1 because French fries are only $1. So now I've got $4 left. Okay. So then my next option is the second French fry is 13 and my first hamburger would be 10. I haven't bought any hamburgers yet. I've only bought a fry. So obviously 13 is greater than 10. So I'm going to buy a second French fry rather than a French fry and a hamburger. Okay. So now I'm sitting on 2 hamburgers. I've got $3 left, right? So with my $3 I have left, I have to decide, am I going to get the first hamburger still sitting over here with 10 utils per dollar, marginal utility per dollar. And over here, my third French fry, I already have 2 French fries. So the third one is not as important. So it's a lower marginal utility per dollar. It's only 8. Well, in this case, the 10 is higher than the 8. So I'm going to buy the hamburger. So now I'm sitting here on my plate and I've got 2 fries and a hamburger and I've spent $4. $1 each for the French fries and then $2 now. Remember the price of hamburgers went up. So now I'm sitting on $2 for my hamburger, $2 for my French fries, my 2 French fries. At $4, I only have $1 left. I can't afford a second hamburger, so I'm going to go and get my third French fry. Good thing, too, because the third French fry would have provided me more utility than the second hamburger. Anyways, the second hamburger was only 7.5. The third French fry would have been 8. So clearly you can see in both cases, right, this marginal utility per dollar idea, we still end up with the same result, that it's going to be 1 hamburger and 3 French fries. Okay, so either way, whether you allocate your money, dollar for dollar, purchase for purchase, or if you work out the possible baskets and the total utilities combined, we're going to end up at the same answer. And that's really cool. Okay. All right. So now what I want you to think about, let's go back to this idea of the budget constraint. We just did an example of what happens to the budget constraint when one of the prices changed. In this case, the increase in price of the hamburgers rotated that budget constraint inward. Now let's assume that your income changes. Now let's say in this case, he lost $1. And so now he couldn't find his extra $1 around his house. Now he's down to $4. So now he only has $4. And let's go back to our original price of $1 each. We'll go back to our very, very original budget constraint. And so you can see it here in red. That was our 5 and our 5, not the blue one that got rotated, but the original red budget constraint where we had 5 hamburgers and 5 fries was affordable with a $5 income and a price of $1 per hamburger, $1 per fry. Now we only have $4, so that's going to shift my budget constraint inward. Notice how it's a shift. The slope of the line stays the same because remember, I told you the slope of the line is P of X over P of Y. In this case, price of fries over price of hamburgers, which is 1 anyways, but -1 because it's downward sloping technically. But in this case, it's a shift inward. So decreases in income, shift inward, parallel. Increases in income, shift outward, parallel, assuming that the prices stay the same, or the constant. Stay constant in this process, okay? So now what I want you to do, try on your own, right, is to solve for how many hamburgers and fries now with only $4 in income. So you can go back and do the marginal utility per dollar approach, or now you can look at, okay, now if the prices of hamburgers and price of fries were each $1 and I only had $4, write down all the possible baskets, starting with 4 hamburgers, no fries, 3 hamburgers, 1 fry, do the total utility in that way. I would attempt it both ways just to make sure that you're getting the hang of it, and notice that your answer will come out the same either approach that you use. Okay, Whew, I think I've done enough to get you guys started. Best way to learn economics is to go do it. So now go do some of the homework that I have assigned. This was only the utility section of the homework. The homework does have an elasticity portion, and I'll be posting that elasticity video probably tomorrow, Saturday, for you, but definitely in advance of when the homework is due, so you have some time to digest that lecture as well. All right, hopefully this was helpful. Again, you can go find, I will not save all of our work on this sheet. I will upload a blank one so that you can then fill in the answers, work through as I am working through. You can fill in the answers, right? Do it yourself, or you can reprint it multiple times and attempt to do it on your own. However that helps you the most. Just practice, practice, practice. I'll post this handout and the lecture momentarily here on Canvas, and hopefully it helps you guys better understand the utility stuff. Still struggling, go watch those videos. See me during my office hours, send me an email, however best. I'm here to help. So keep up the good work. You guys are doing awesome, and have a good weekend. All right, I'm gonna get out of here. Hopefully if I remember how to exit out of Zoom. Stop my screen sharing, exit full screen, and then how do I get out of here?